In all the problems we've done so far, we've been able to draw our vector addition and the way we think about one vector at a time. Now in this problem, we are just told that two forces are acting on a point, so here's our point. Two forces of 15 and 22 newtons are acting on that point. We aren't given a direction, so we can draw this however we want. All we know is we have some force of magnitude 15 and some other force of magnitude 22. Now we know the angle between those forces is 100 degrees. So if we want to draw it a little bit more to scale, we can make sure the angle between our two vectors is 100 degrees. And then we want to find out the magnitude of the resultant force. Now remember, the resultant is whatever vector happens in between them. Hard to draw, or hard to really know how exactly to draw it without having more information. And also, as we draw that, we don't really have a triangle to work with. However, remember, vector addition is commutative, meaning we can draw these vectors in either order, and we can, while they are both happening on the same point at the same time, we can think about it as one vector at a time. So another way we can draw this, I'm going to get rid of that green line for now. So instead of thinking of it as both on the same point, we can think of this as vector 15 happened first, and then we're going to move where we draw vector 22 so that it begins at the end of vector 15. So we'll draw it over here instead. Now remember, the resultant is what goes from start to end. So our start was our point. Our end was after we drew both vectors. So our resultant vector that we care about is one that starts here and goes towards the end. So notice, that's about the same as I had drawn as I was just guessing a minute ago. And remember, vector addition is commutative. So that means we also could have drawn 22 first and then drawn 15 at the end of it. Either way, both forces are acting on the same point. That green line or green vector represents how the point would move with both of those forces. And this is what we call a vector parallelogram. So because they're commutative, we can draw it either way, we create a parallelogram. Remember, parallelograms mean opposite sides are equal and parallel. Well, both of our pink vectors here are 22, and the forces are the exact same direction, so they're going to be parallel. Both of our blue forces are 15, and again, they're going to be parallel because they're the exact same direction. So due to this parallelogram, being a parallelogram, that means we can use some properties. If we know it's 100 degrees at the bottom, well, we know the angle between them is 100 degrees at the top. And then what's more important in this vector parallelogram, because what we really want is to find this distance of our resultant, we need to know what this angle is down in the bottom left or bottom right or top left. Well, what's important in parallelogram is that the two angles add to 180. So adjacent angles in a parallelogram add up to 180, which means if it's 100 degrees between the two vectors, well then we just do 180 minus 100. We know that the other two angles in this parallelogram are 80 degrees. Now that we have that angle, we have triangles we can work with where we have side angle side, which means we can use the law of cosines in order to find that distance for D.